Hey guys, so this is the Halo mirror. It's a smart mirror built on Magic Mirror 2. Our goal was to make a cool looking, futuristic mirror that tells different people about their day, commute, the weather, and a bunch of other useful stuff. And honestly, we probably spent way more time on this than we should have, but the product that we have created is amazing. The first feature I want to highlight is our login system. When a recognized person comes in front of Halo, their pre-configured modules will show up. When they leave, their sensitive data will go with them. Watch. To do this, we're using OpenCV with a deep neural network. It sounds super complicated, and I know we learned a little bit about machine learning class, but it's actually not terribly hard to implement because of all the online tutorials that are available. Our login feature also makes sure that there is still some information that makes this a smart mirror even if a user's not logged in. So let's say a complete stranger walks up to the mirror. Then it'll still show the time, the date, the weather, but none of the sensitive data. So let's say you are a pre-configured user. What kind of data will you see? The next feature I want to point out is the commute data that calculates your commute based on what day of the week it is and stuff on your Google Calendar. It tells you how long to get to school and the route. It's all built on top of the Google Directions API, so all the tough calculations are done on their end. Right above that, you'll see custom news headlines based on the user's preference. For me, I'm gonna have New York Times RSS feed load into this. In the morning when I use Halo Mirror, I'll be able to see really important headlines. Those were all passive features that connect to the internet and give you information about your day ahead. But we've also wanted to create some interactive features that make it a futuristic experience. There are two ways to interact with Halo Mirror. First, you can just say Halo, and then what you want it to do. Some acceptable commands are like, Halo, where's my package? Or, Halo, lights off. Halo, play music. Halo, YouTube eye makeup tutorial. Now you can do your makeup and watch that tutorial in the same place. The second way we've made the mirror interactive is through touch. When you're playing music, there's a Spotify player on the bottom left. You can skip a song, pause it, go back, turn on shuffle, and change if the playlist loops or not. Since Magic Mirror is built on Node.js, it's essentially a web page, and a lot of interactive elements already are touch-friendly. For example, the YouTube video with the makeup eye tutorial before. You can also just press on the video and it'll pause the video. Press it again and it'll play. Yeah, and that's really it. The Halo mirror. Oh yeah, and it's a mirror too, if that wasn't obvious.
Hello everyone, I'm Özlem.
And I'm Patam again.
Okay, let's see our hardware design of our project. So this is our hardware design from front to back. We decided to add touch to our mirror, so there is an IR touch frame in front. Instead of glass, we use two-way mirror foil and placed it directly on TV. Then we attach the webcam to the frame and all computing electronics behind the TV. So our finished hardware product was sleek and has only one visible power cable coming out of front. When mounted to wall, it will look like a mirror. The phone stand would also be removed. Okay, let's see our real side profile of Halo. From front to back, you can see our IR frame, mirror foil, display, and power. Okay, you also see our Raspberry Pi cable and power in that picture. Most of these features that you see right now can be integrated with use of online modules found on the Magic Mirror GitHub. There is a lot of tough debugging, however, because not everything works out of the box. On top of that, our combination of modules will be unique, so you need to ensure that they interact with each other correctly. Our voice recognition, for example, could not initially open YouTube. So we found a module that could and linked the front of one module to back of another.
Yeah, and if you guys are interested in the specific modules we used with the Magic Mirror, if you just take a look at our report, we're going to include links of the open source ones that we utilized. So, everything that we have set, every goal that we set previously, it's been hit, and we managed to get past the foil and glass sourcing. That was really a big issue for us. We ended up using foil, but it was really tough and very labor intensive. It took us about six tries. It took 6 tries, but it was very nerve wracking because to tint or put foil onto a TV display instead of putting it onto glass, you have to spray the TV with a lot of soapy water, and then we had to like tape the edges and make sure that no water got in. So it was definitely very nerve wracking, but we just chose to use labor instead of just like a lot of hard work instead of getting the right part. But yeah, so like every single goal that we set before is done, like the voice integration, the smart light control, touch, the multiple users, face login, and music. It's all working. So I'm just going to take you through our software steps, saying that if you wanted to build a smart mirror yourself, what you would do. The first step is to figure out like what computer you would use it on, and for us we set up a Raspberry Pi with the full Raspbian version. There are light versions of the operating system of Raspbian that you can install, but they are not compatible with Magic Mirror. Then you can go to the Magic Mirror GitHub and it'll explain everything on how to install it. There's a bunch of dependencies and a lot of steps you have to take, so it's just best to refer to that and get Magic Mirror working and running. Then after that, you can go through the Magic Mirror GitHub, and they have a third-party modules section. And in that section, you can read about other modules people have created. There's also a template on how to create your own module. So going forward, if you understand JavaScript enough and Node, you would be able to put in some of your own features into the mirror. So yeah, you basically just want to find the third-party modules that work. And then you need to spend a lot of time installing them, because of course this is open source code, and a lot of the developers, some of them are pro developers, some of them are not so much. It's not like software that's people are being paid to make. It's software that's just for hobby, so there is a lot of different coding styles, and there's a lot of stuff that just doesn't work correctly and the way it should. And so even though we use third-party modules for some of our parts of our mirror, it was still hard to integrate them because we needed to get the APIs running. There was also this whole debacle where we were trying to get music streaming through Alexa voice services, and in order to do that, you had to get your device certified by Amazon as a music playing device, and it's like kind of annoying. There's like a whole bunch of regulatory issues too with voice services. There's just, for every single feature that you want to put in, there's just a different route of steps, and it's just going to take a little bit of time. But if you're willing to put in that work, you can get a product like ours. And so yeah, write new JavaScript code. Basically, the modules you choose are going to be unique because you chose them, right? And so there's no system to make sure that they all work together correctly. There's a general notification systems that allow one to communicate with another, but you have to write the code that connects each module if you want them to truly work cohesively. So this is just a few pictures of some of the big software we use. We use the Magic Mirror framework, obviously. We used a bunch of Google APIs. We used the Google Directions API to get the commute time. And I think there was another Google API that we used as well. We used the AVS Alexa voice service to get Halo, basically. We also trained a voice model for custom voice detection. And Magic Mirror is on Node, so we're using JavaScript. And OpenCV for the facial recognition as well, as long as a few Python libraries to train face data and ensure that detection and login was working correctly. Not pictured here, we also use some of Roku's control APIs. Our display is actually a Roku TV, so we're able to control it wirelessly, and we can send HTTP requests to the TV itself. And so we integrated that with the facial recognition system that was already available, and then we put them all together. We trained our data, and we made sure that the TV would actually turn on and turn off when the person's there. So and not there. So like usually, in magic mirrors, a big problem is that people see that there's like a light behind the mirror and it looks like there's a TV behind it. But for us, we solve that problem by just making sure that it only turns on when there's a recognized user in front, and we put the brightness to a certain level using Roku's API. So here's an example of what like the code would look like if you were to do it. On the right, you'll see the directory for our modules, and there's subfolders for every single module. Some of these we didn't end up using, but we tested a bunch of them, and this is just what our folder looked like at the end of all of our work. And on the left is a really important file. It's the config.js file for Magic Mirror. And in that file, you say, oh, I want this module to show on the top left. I want it to have these specific configurations. And it's basically like a high level understanding of what your mirror is showing. But the actual code for functionality is within these folders on the right, which have a lot of JavaScript files that interact with each other. And so once you have that software done, it's actually better to make the software first and then go build the hardware. We got a little excited about the project and got some of our hardware early, which kind of made it better, honestly, because we got it before everything got really bad, although some of the stuff we were only able to get afterwards. But like, it's better to have the software in hand and make sure that works first, and then you can commit the money for the hardware. So we got a touch frame, which is the IR frame, and we got that from Alibaba, which was in China. So we got an external supplier. In my experience, that's probably the best way if you want to go with touch frames, because if you try to buy anything in America, it's like so expensive, as opposed to, it's still gonna cost significant amount of money, I guess, in China, but it's like definitely way cheaper than if you were to source it in America, basically. And you want to display with a good contrast ratio. The reason for this is, like I was saying earlier, how the light shows through the mirror. If the black levels on the TV look really black, then they won't show through the thing. So you could probably get away with keeping the display on all the time. But with our solution, it was a good way to work around that. And we kind of fixed the problem that a lot of Magic mirrors have that seem to be not fixed before. On top of that, we used the PSI camera. This is for the PlayStation. If you guys ever had like a PlayStation 3 or know about those, they have a camera for games where you can interact like motion and like move your head and stuff, and it'll control elements in the game. It didn't really take off, and like people didn't really buy the cameras. And so basically you can get this PSI camera for like $6. You can use it as a webcam too, if you're using certain operating systems. But it's also really good for computer vision or facial recognition, because the TV, it was designed for TV light. Like if the room has lights completely off and the TV is just on and there's minimal light on a person's face, they'll be able to get detected with a PSI camera. It was specifically designed for that purpose. It's cheap, and so it's actually used in a lot of computer vision research as the camera hardware. And so this one, I say you can either use mirror foil or glass. Basically, there's an effect that happens, obviously, with the TV. You want to see what's on the display, but at the same time get a reflection. So you need to either tint a mirror foil onto a piece of glass, or you can get a piece of glass that actually already is two-way, and it only lets some light in and some light gets reflected. So benefits and drawbacks: if you do choose the foil method, it's definitely a lot more labor intensive, and you still probably should get glass. We weren't able to. We put it directly on the display, which is a big no. But you should definitely get a plain piece of glass and then put the foil on that, and then put that glass in front of the display rather than putting it on the display itself, because the electronics are very finicky. Or you can just get the glass. The glass is actually really expensive, so we don't recommend that route. We just recommend going mirror foil with a piece of glass on the display. And then you can follow our diagram from front to back, just like Ozden said, shown earlier. You can assemble it just that way. We use hot glue gun to get our frame on, and it's actually very rigid, surprisingly. And yeah, so honestly, we didn't think we'd be able to do it. There's a lot of stuff that we didn't know anything about before we started this project, and we only saw a few YouTube videos. explaining vaguely how to do it, and we just really weren't sure. And somehow we were able to put it all together. It was really fulfilling, and for me at least, this was something that I had always wanted to do. I remember seeing YouTube videos about how to make it a few years ago, and then like I finally actually got time to do it, and like I had the motivation because it was for a class, so I put in way more work than I should have, honestly. But yeah, I'm really happy with the results, and we really made a great product. So you can find out more about it in a report. If you read the report, there's like some more technical details, and I think there you might find it useful. I talk about some of the hardware choices that you can make when you're building your own, and yeah, I think that's really it. Thanks for watching, guys, and I hope everything is good with you guys, and you guys stay safe.
Thank you.
Thanks. Bye bye.